Okay, so this is section 1.3, slope fields and solution curves. This is going to be a very short section. Technically, I don't need to cover this section because you actually need software for this. And some students have it, some don't, and it's quite expensive. But I did want to just touch on this just because, I mean, we're working with differential equations, and you've been solving them using calculus, right, and just certain techniques. But it's important to understand visually what these differential equations mean. So the goal is to get a handle of, differential equations without actually solving it. What does it look like? So we have slope fields, okay, or sometimes called direction fields. And a slope field really just represents a differential equation. So this is a slope field, right? I mean, think of just a big field, and you have all these little slopes, right? These maybe negative slopes, right? You might have positive slopes here, right? There's a little positive slope there. So this is your slope field. So let's see, maybe, okay, so slope field, right? That's all of this, right? This is your, your dy dx. And actually, in this specific case, this differential equation is equal to 9.8 minus v over 4. And we'll talk about that in a different section. But so here we have a differential equation, and this is its slope field, right? There's a bunch of little slopes, and okay, so we have and slope fields, and we have solution curves. So solution curves in blue. And I want you to connect these slope fields, right, and or little slopes into an integral curve. So all these little slanted line segments, right, give you the solutions of the differential equation, right? All you really have to do is connect the slopes, and you'll get your integral curve. So again, here's an infinite number of solutions, right? There's a bunch of solutions here. And I don't know, I'm just going to pick a point. We're going to give you an initial, this is like an initial condition. I don't know, let's just say 5 comma 30 is right there. Okay, so one of the solution curves, and you'll do this on your homework, which is very easy, is just, connecting the slopes and trying to see, okay, that's one solution, right, to the differential equation, right? That might be like y1 of x. Another one could be, oh, I don't know, maybe this one, right? You can say y2 of x. Let's see, this one, these are some nice horizontal slopes, right? These are probably slope 0, right? That can be another one. So you can, again, these are all solutions. Solution to differential equation, solution to differential equation, solution to differential equation, and so forth. So there's a family of solutions to the differential equation. So again, direction field, slope field, the differential equation is represented by this field of tiny slopes at specific points, and the solution curve, right, you're solving for your formula, is going to be these curves, these solution curves, or sometimes called integral curves because you are integrating, hence the name. Integral curve. And on your homework, so I'm looking just quickly at, so on page 27 on your homework, you'll have these little blue dots, and when you draw the solution curve, I mean, make sure you draw integral curves through those blue lines or those blue dots. And if you're not sure, I mean, the answers are in the back of the book. But again, this is kind of the big picture. After this class, you'll definitely be working probably with Mathematica or Maple to graph these differential equations. So that's it for 1.3, and you have a few homework problems.